You've probably seen a ton of irrelevant news today, but let me tell you something. While everyone's looking the other way, something massive and silent is happening right above our heads. Today, we're not bringing rumors, we're bringing solid evidence of two anomalies. A giant that defies the definition of a comet, and today's main character, a visitor from outside our solar system. Let's get straight to the point with 3I Atlas. What you're seeing on screen right now is pure gold. Forget computer simulations or CGI. This is raw data, real photons hitting the sensor. I want you to pause and look at the structure. We've got the usual, the bright core and that tail stretching out behind it, all normal so far. But look at this, right here at the front. There's a sharp projection, a trace pointing in the opposite direction of the tail, as if it were leading the way. In previous photos, it was barely noticeable, but in this new image, it's undeniable. It's bright, solid, and it has structure. And to give you a sense of the quality of this image, this isn't just a simple camera click. Achieving this level of sharpness required stacking 57 different exposures, each a full minute long, pushing a dedicated ZWO camera and an ASCR telescope to their limits. We're talking about an entire hour capturing light to reveal that strange detail your eyes are seeing now. To understand why this matters, we need to go back to the original source. This didn't come from a perfectly polished NASA computer simulation. This is trench-level astronomy. We're talking real sky conditions, manual calibration, and live tracking. And it's right there where we find the detail that keeps me up at night. That frontal jet. It doesn't look dispersed or chaotic like a comet's typical gas. It looks focused. And let me tell you, interstellar objects are not supposed to have that kind of precision. Now get ready, because this is where things get technical and fascinating. Look at this raw image. At first glance, it looks like a mess, right? Just noise and stars streaking across the frame. But fix your eyes on that dark smudge in the center. That's 3I Atlas hiding in the static. But when we bring out the heavy artillery, rotational gradient filters, and Larsen-Sechenina techniques, the same tools the pros use to scan comets, the magic happens. Boom! The noise fades, and that bright point appears at the center. We may be looking, for the first time, at the actual nucleus of the object. I want you to notice the difference. The background stars leave trails, they move, they blur. But that central point, that point is locked in. It doesn't smear, it doesn't shake. It stays solid in every processed frame. In data science, if something appears in the same place across multiple independent shots, it's no longer noise, it's a signal. The original source is cautious, using phrases like might show, because that's how real science works. But between us, when you see that level of consistency, coincidence leaves the equation and evidence steps in. My friends, it is very likely we're looking directly at the solid heart of a traveler from another stellar system.
But hold on, because 3I Atlas isn't the only enigma out there. If we swing the camera toward deep space, we find something that makes almost everything else look tiny. Look at this. We're talking about C 2014 UN271, better known as Bernardinelli-Bernstein. And this isn't a simple rock. Estimates say it's 150 kilometers in diameter. Just to give you an idea, it's one of the most colossal comet-type objects we've ever seen. Now, forget the concept art for a second. Let's get into hard science. What you're seeing here is real data, On the left, the telescope's direct image. In the middle, the model of the coma. And on the right, the isolated nucleus. Officially, they call it a comet, but this giant doesn't play by the usual rules. It's already active and releasing gas, carbon monoxide, CO2, ammonia, and it's doing it ridiculously far out, beyond Saturn. This shouldn't be happening that far from the Sun. Right now, it's near Uranus and getting closer. But here's the strangest part. At its closest point, its perihelion, it won't even cross Saturn's orbit. It'll stay around 11 astronomical units away. Why does this matter? Because it means this object has never been cooked by the Sun. It's a time capsule, pristine, ancient, extremely volatile material. We have no idea how it's going to react. It might stay quiet, or it might erupt with massive outbursts and jets of gas that change its velocity. Being the second largest object of its kind, whatever it does will be on an epic scale. Call it a comet, a minor planet, or an anomaly, one thing's for sure: it's gigantic, it's active, and it's headed toward the inner solar system. And now, I want to hear from you. Do you think 3I Atlas is just a simple visitor, or is there something more to it? And what do you make of this giant Bernardinelli-Bernstein? Drop your theories in the comments. I'll be reading them. And you know the drill. If you enjoy exploring the unknown in deep space, smash that like button and subscribe so you don't miss the next update.